Okay, you can ignore everything over here if you're a pre-calculus student. This is variation of parameters in differential equations, which is one of the more challenging things, not terribly challenging. Anyhow, you don't want that if you're a pre-calculus student. You have something to look forward to. You have all this to look forward to. Here, we're simply dividing x plus 3 into x squared plus 5x plus 6 using the division algorithm. Now, everybody did quite well with this. A couple people needed a little bit of refresher. Some people just went right through it and said they were kind of surprised they remembered it. So it's something that isn't too bad, but you got to be careful about signs, so let's look at this somewhat carefully. Divide x plus 3 into x squared plus 5x plus 6. We start by dividing x into x squared. And x divided into x squared, well, x squared divided by x is just x. So we get x. Now we multiply x by x plus 3. We get x by x. X times x is x squared. X times 3 is 3x. Now you see that little negative sign that I wrote in there. Originally I didn't have that, but I just wrote a little tiny negative sign here to remind myself that this needs to be a subtraction, that I'm subtracting this from this. So I think of adding 5x to negative 3x maybe. So 5x minus 3x is 2x, and we bring down the 6. And then we divide x into 2x. We get 2. 2 times x plus 3 is 2x plus 6. So here it is. It divides off. We get an even division. And we conclude then that since this divided into this gives us this, that this times this should equal this. And that's really important to understand. And I think people understand that pretty well. Which means that x squared plus 5x plus 6 is thus equal to x plus 3 multiplied by x plus 2. Of course, it's really easy to factor this, and you can get this without doing long division. But long division works. And if you have something bigger than a quadratic, often it's necessary to use long division or equivalent synthetic division, which I don't talk about, but which people kind of like, so you're welcome to learn it as long as you know how to do long division. I'm okay with that. Okay, so anyhow, if you have something of higher order or degree, a polynomial of higher degree, often you have to do a division in order to aid the factoring process. Well, let's try something different. Let's see what happens if we try to divide x plus 1 into x squared plus 5x plus 6. Well, since x squared plus 5x plus 6 is x plus 3 times x plus 2, we probably conclude that x plus 1 is not going to divide it evenly, is it? Let's see what happens. Okay, we divide, and it's very straightforward. X into x squared is x. X times x plus 1 gives us x squared plus x. We put that little negative there. It's not really part of it. I'm actually going to erase that. I'm better erase that one too. But I put that there to remind myself to subtract. Okay? Now that becomes important if you get a negative here. If you had x squared minus x, you maybe want to write a little plus there to remind yourself that you're not subtracting, you're adding, because there's two subtractions involved, and it's probably going to get messy. You're going to be prone to make a mistake. Anyhow, if you're careful, you'll get it. 5x minus x is 4x. Divide x into 4x, you get 4. 4 times x plus 1 is 4x plus 4. You subtract, and by darn, you got a remainder of 2. So it didn't divide evenly. Well, what do you do when you have a remainder? Well, that means that this could also be expressed as x plus 4 plus 2 over x plus 1. So that x squared plus 5x plus 6 is x plus 1 multiplied by then x plus 4 plus 2 over x plus 1. And this form could be very relevant to some of the things we're going to do before too long, involving things like slant asymptotes and other results that are relevant to the graphing process, okay? So, well, we said that x plus 1 times x plus 4 plus 2 over x plus 1 should then equal x squared plus 5x plus 6. Well, we do the algebra and we show that it's so. X plus 1 times, we just distributive log x plus 1 times x here, x plus 1 times 4 here, x plus 1 times 2 over x plus 1 here. And multiply that out. This gives us x squared plus x. This gives us 4x plus 4. And this gives us, well, people love to cancel, and they always do it wrong, and so I don't even like to use the word. We rearrange this as x plus 1 over x plus 1 times 2. Then, x plus 1 over x plus 1 being equal to 1, then this whole thing is just 2. So we never had to cancel anything. Cancellation is overrated, and if it's not done in a context of quite rigorous understanding of algebra, at least at the Algebra 1, Algebra 2 level, it's not worth doing. Okay. You gain more insight from doing this, and you're more likely to not screw something up by doing an incorrect cancellation. So I kind of advocate that you make sure that this sort of thing works. Anyhow, this gives us then, well, x squared is x squared, 4x and x is 5x, 4 and the 2 that we get from this is 4 plus 2, which gives us 6, and there we have our x squared plus 5, where x plus 6, and by dang, it works out. Okay. Now, let's divide x minus 1 into x cubed plus 4x squared plus x minus 6. Well, you know, I allowed the class to work on this, and everybody pretty much did it right. So I saw no reason to write it all out. The process is the same, and people seem to be pretty secure and pretty good with the process. So, our conclusion from the fact that we do get, if we divide this into this, we get our x squared plus 5x plus 6, okay? And there's no reason we would have expected that. I just set it up so that would happen. But that means that this polynomial, x squared plus 4x squared, x cubed plus 4x squared plus x minus 6, is equal to x minus 1 times x squared plus 5x plus 6. Okay, well, if we're trying to factor this, that's really useful, because then we're down to a quadratic. Okay, so this is a quadratic, and we know this factors. It gives us x plus 2 times x plus 3. If it was some other polynomial where we got an even division by x minus 1, it would be x minus 1 times whatever quadratic we get when we do the division. Now, that quadratic can be factorable, okay, as x squared plus 5x plus 6. It could be factorable technically, but not really, because you have things like square roots and all kinds of weird things in your factors, and you're never going to find them except by using the quadratic formula. But of course, the quadratic formula is always a valid way to do this. If we use the quadratic formula on this, we would find, and did I do this? I thought I did this someplace, but I don't see it. Anyhow, we would find that x is negative 5 plus or minus the square root of 5 squared, which is 25, minus 4ac, which is 24. So we get negative 5 plus or minus the square root of 1, all that over 2. Negative 5 plus 1 over 2 is negative 3. It's negative 2, negative 4 over 2. And the other solution is negative 3, meaning that our factored form would be x plus 2 times x plus 3. Because the quadratic formula tells us where the thing is 0, and thing's going to be 0 if x is opposite to whatever this is. Okay? So the negative 2 we get out of the quadratic formula means we better have x plus 2 here. So when x is negative 2, this gives us 0 and makes the polynomial 0. And similarly for x equals 3. Okay, so now we have the factored form in any case of this polynomial. The other thing can happen when you do this is you get down to a quadratic and the discriminant is negative, so you have no zeros, so there is no further factoring. Okay, well, this tells us that the zeros of this polynomial are what? From x minus 1, we see that 1 is a 0, because 1 minus 1 is 0. And 0 times all this is 0. And 2, negative 2, is a 0, because that makes this term factor 0. And negative 3 is a 0, because that makes this factor 0. Any factor is 0, the product is 0.